Hey there, fellow physics enthusiasts. Today, we're diving into the fascinating world of physical quantities in physics. Specifically, we'll be exploring the relationships between force, mass, and acceleration. Now, did you know that force is directly proportional to mass? That's right. As mass increases, so does the amount of force exerted on an object. This is a pretty cool concept to remember, and it can help us understand how different objects interact with one another. But wait, there's more. Force is also directly proportional to acceleration. When an object starts moving from rest or changes its speed, force comes into play. The greater the change in velocity, the more force is required. This means that if we want to speed up or slow down an object, we need to apply more or less force respectively. Now, let's dive a little deeper. The relationship between force, mass, and acceleration is famously encapsulated in Newton's second law of motion, which states that force equals mass times acceleration, F equals ma. This equation is like a secret formula that unlocks a whole world of understanding about how things move. Imagine pushing a shopping cart. If it's empty, it zips along with little effort. But if you load it up with heavy groceries, you'll find it takes a lot more effort, more force to get it moving. That's mass in action, but it gets even more intriguing when we consider direction. Force isn't just about pushing harder, it's also about where you direct that push. When you apply force in the same direction as an object's motion, it speeds up. If you apply it in the opposite direction, the object slows down. This is why brakes are so important in vehicles. They exert a force in the opposite direction to reduce speed. Furthermore, this principle isn't limited to just everyday experiences. It applies to everything from the smallest particles in physics to massive celestial bodies. The planets orbiting the Sun, for instance, are all due to gravitational force acting as a pull, where their mass and the acceleration towards the Sun balance out in a spectacular dance of motion. So next time you're pushing, pulling, or just observing motion in action, remember the powerful relationship between force, mass, and acceleration. It's a fundamental concept that truly shapes our understanding of the physical universe. So there you have it, folks. A quick overview of how force relates to mass and acceleration in physical quantities in physics. I hope this helps you better understand these concepts and appreciate the amazing world around us. Thanks for tuning in, and if you enjoyed this video, please don't forget to hit that like button and subscribe for more exciting content like this. Until next time, stay curious and keep exploring.